Imagine standing at the edge of a cliff, the wind whispering secrets through your hair, and below you, an endless valley stretches beyond the horizon. Now, imagine that valley isn't the only one. In fact, it's just one among countless others, valleys stacked upon valleys, worlds upon worlds, universes upon universes, each one potentially as real as the one you inhabit. This is the realm of the multiverse, a concept so vast, so unfathomable, that it challenges not only our understanding of physics, but of reality itself. Tonight, we step beyond the familiar stars, beyond the galaxies, and even beyond our own universe, to ask a question that humankind has only just begun to grapple with: how many multiverses are there? Our story begins not with a telescope, but with a question. For centuries, humans have looked up at the night sky, marveling at the stars, wondering if we were alone. The more we explored, the more it became clear that the universe was staggeringly immense. Galaxies swirled in numbers that dwarfed imagination, stretching across distances so vast that light itself takes billions of years to travel from one corner to another. But as we mapped the cosmos, another question arose, one that seemed almost heretical at first: what if this universe, as vast as it seems, is just one of many? The idea of multiple universes, or multiverses, was once confined to the realm of science fiction, whispered in the pages of novels or depicted on the silver screen. Yet, in the quiet corridors of theoretical physics, it began to take a more serious form. The seeds of the multiverse concept emerged from attempts to understand a mysterious period known as cosmic inflation, a fraction of a second after the Big Bang, when the universe expanded faster than the speed of light. This expansion was not uniform, it was chaotic, patchy, and turbulent, suggesting that different regions could have inflated in different ways. If this were true, then our universe might be just one bubble in a vast cosmic foam, each bubble a separate universe with its own laws of physics. This is known as the bubble multiverse, and it presents a mind-bending possibility: there could be entire universes where the stars never formed, or where gravity is so weak that matter never coalesced into galaxies. Perhaps in one universe, life evolved entirely differently, or perhaps it never evolved at all. Each bubble floats in a grand cosmic ocean, isolated from the others, yet bound by the same underlying rules that govern the multiverse itself. The number of these bubbles is not merely large, it is potentially infinite. But infinite, in cosmology, is not always a comforting concept. It is both liberating and terrifying, because it forces us to reconsider what we mean by everything. Yet, the bubble multiverse is only one possibility. Another framework arises from quantum mechanics, the branch of physics that governs the behavior of the very small. At the quantum level, particles exist in states of probability, existing in multiple states simultaneously until observed. This strange principle, known as superposition, led some physicists to propose the many worlds interpretation. According to this interpretation, every possible outcome of a quantum event actually occurs, but in a different, parallel universe. If a particle can spin clockwise or counterclockwise, in one universe it spins one way, and in another, the opposite. Extend this principle to every quantum event, and the implication is staggering: there could be an unimaginable number of parallel universes, each differing from our own in ways both subtle and profound. In one universe, you might have chosen a different path in life, studied a different subject, lived in a different city, met different people. In another, the dinosaurs never went extinct, and mammals never rose to dominance. The many worlds interpretation suggests a cosmic kaleidoscope of possibilities, each universe branching off like an endless tree of reality. The math that underpins this idea is elegant, almost poetic, yet it is profoundly counterintuitive. Our minds are built to understand a single, continuous reality, but the multiverse defies that instinct. It challenges the very notion of identity, of choice, of consequence. Then there are multiverses suggested by string theory, the ambitious framework that attempts to reconcile quantum mechanics with gravity. In string theory, the fundamental constituents of reality are not particles, but tiny vibrating strings, each vibrating in its own unique way. The vibrations determine the properties of particles and forces, and, intriguingly, string theory predicts the existence of extra dimensions, far beyond the three of space and one of time that we experience. These extra dimensions may allow for universes with entirely different physical constants. In some, gravity may be stronger, in others, electromagnetism may dominate, and life as we know it might be impossible. This landscape multiverse paints a picture of an almost inconceivably large cosmic terrain, with a nearly infinite number of valleys, each corresponding to a universe with its own unique laws. Yet, despite these theoretical landscapes, a question looms: how can we know if these universes exist? After all, by definition, they are separate from our own, often beyond the reach of observation. Some physicists suggest that traces might be detectable in the cosmic microwave background, the faint afterglow of the Big Bang, or in subtle anomalies in the distribution of galaxies. Others propose that gravitational waves, ripples in the fabric of spacetime, might carry the fingerprints of other universes colliding with our own. But so far, evidence remains elusive, and the multiverse hovers at the boundary between speculation and scientific possibility. The philosophical implications are just as profound as the scientific ones. If multiple universes exist, what does that mean for our understanding of reality? Are we unique, or just one version of countless possibilities? Does the existence of other universes diminish the significance of our choices, or does it elevate them, casting our lives as a rare convergence of probabilities? Some argue that the multiverse offers an elegant explanation for fine-tuning, the observation that the physical constants of our universe seem precisely calibrated to allow life. In a multiverse of infinite variety, it is perhaps unsurprising that at least one universe would have the right conditions for stars, planets, and life to emerge. And yet, the multiverse is not without controversy. Critics argue that it may be untestable, placing it outside the realm of empirical science. Can a hypothesis be scientific if it cannot, even in principle, be falsified? The debate touches on the very nature of scientific inquiry, forcing us to confront the limits of observation and imagination. In this way, the multiverse is not just a scientific hypothesis, it is a mirror held up to the human mind, reflecting our deepest questions about existence, reality, and the nature of everything that is, or could be. To truly grasp the scale of the multiverse, we must expand our minds beyond the familiar. Picture our universe as a grain of sand on an endless beach. The beach stretches in every direction, each grain a universe with its own stars, planets, and possibilities. Now imagine beaches upon beaches, shores beyond shores, and then a cosmic ocean beyond that, a reality so vast it defies comprehension. This is the frontier at which we stand, a threshold between the known and the unknowable, where imagination and mathematics collide, and where the simple question, how many multiverses are there, becomes a doorway into the infinite. As we begin this journey, we will explore the leading theories, the breathtaking possibilities, and the subtle clues that suggest our universe may be just one of many. We will travel through cosmic inflation, peer into the quantum world, and navigate the intricate landscapes of string theory. Each step will stretch the boundaries of our understanding, inviting us to see reality not as a single stage, but as a vast theater of countless worlds, each with its own story waiting to be told. To navigate the labyrinth of multiverse theories, we must first anchor ourselves in the concept of cosmic inflation. Imagine the universe at its very beginning, a tiny, dense point containing everything that would ever exist. In a fraction of a second, this point expanded exponentially, stretching far beyond comprehension. But this expansion was not smooth. Tiny quantum fluctuations were magnified, creating regions with different densities, temperatures, and even physical laws. In some areas, inflation slowed, allowing matter to clump into galaxies and stars, forming universes much like our own. In others, expansion continued unchecked, producing empty, barren realms. This patchwork of conditions hints at the possibility that our universe is just one bubble in an endless cosmic foam. Physicists like Alan Guth and André Linde, pioneers of inflationary theory, began to realize that this eternal inflation could naturally give rise to a multiverse. In Linde's model, inflation never completely stops, it continues in some regions, creating new universes in a process that might never end. These universes are causally disconnected, meaning their events can never influence ours, yet they coexist in a grander structure of spacetime. Imagine countless bubbles forming in an infinite cosmic ocean, each a self-contained reality with its own unique story. The sheer scale of this possibility is difficult to internalize. If inflation is eternal, the number of universes could literally be infinite, a never-ending proliferation of cosmic diversity. Meanwhile, the quantum perspective opens a different window onto the multiverse. In our everyday experience, events appear linear and deterministic. If you drop a cup, it falls. But at the quantum level, particles do not behave this way. They exist in superpositions, multiple possibilities simultaneously, until a measurement is made. Hugh Everett III, in the 1950s, proposed a radical interpretation of this phenomenon. He suggested that every quantum event spawns a branching universe. In other words, reality constantly splits into multiple versions of itself. This is the many worlds interpretation, and it implies a staggering scale of parallel worlds. Every choice you have ever made, or could have made, exists in some universe. Every path not taken, every different decision, unfolds somewhere in this infinite tree of reality. Consider a simple coin toss. In our universe, it lands heads. But in another, it lands tails. Multiply this branching process across every particle interaction in the universe, across every moment in time, and the number of universes becomes incomprehensibly large. According to some estimates, there could be more universes than there are particles in our observable cosmos. Yet this multiplicity is not just a mathematical curiosity, it has profound implications. It challenges our understanding of fate, free will, and identity. If every possibility occurs somewhere, then certainty is an illusion, and the notion of a singular, unique self becomes fluid. String theory adds yet another layer of complexity. This ambitious framework seeks to unify all fundamental forces of nature, gravity, electromagnetism, and the nuclear forces, under a single theoretical umbrella. In doing so, it reveals a rich landscape of possible universes, each with different physical constants. The vibration of strings determines particle properties, and subtle variations in these vibrations could produce dramatically different realities. Some universes might have stronger gravity, collapsing into black holes before stars can form. Others might have weaker forces, producing a diffuse cosmos where matter cannot coalesce. The string landscape is enormous, perhaps containing 10 to the power of 500 or more possible universes. Each is mathematically consistent, yet wildly different from our own, creating a staggering tapestry of possibilities. While these theories are compelling, the question remains, how could we ever detect another universe? After all, if these realms are causally disconnected, their light and energy cannot reach us directly. Some researchers suggest indirect signatures might exist. For instance, a collision between our universe and another bubble in the distant past could leave subtle imprints in the cosmic microwave background, the faint afterglow of the Big Bang. Patterns of unusual temperature fluctuations or circular anomalies could be remnants of such cosmic encounters. Similarly, gravitational waves, ripples in spacetime caused by massive cosmic events, might carry evidence of interactions beyond our universe. Though no definitive proof exists yet, these possibilities hint that the multiverse might not be entirely beyond reach. Another intriguing approach arises from the anthropic principle, the observation that the universe appears fine-tuned for life. The values of fundamental constants, like the strength of gravity or the charge of the electron, are remarkably precise. A slight variation in any of them could render the universe lifeless. Some scientists argue that in a multiverse of infinite variety, it is not surprising that at least one universe would have the right conditions for life. Our existence, then, is not a miraculous coincidence but a statistical inevitability among countless universes. The anthropic principle does not prove the multiverse, but it provides a framework for understanding why our universe appears so exquisitely balanced. Even with these models, the multiverse challenges the limits of observation and imagination. Our brains are wired to perceive a single, continuous reality, yet modern physics suggests a reality far richer and stranger. The multiverse is not a single theory but a spectrum of possibilities, each supported by a different branch of physics. From cosmic inflation to quantum branching to string landscapes, the picture that emerges is not just one of extraordinary scale but of profound philosophical depth. It invites us to rethink our place in the cosmos, our uniqueness, and the nature of existence itself. To visualize this, imagine standing in a vast forest. Each tree represents a universe. Some are familiar, with paths and clearings much like our own experience. Others are alien, twisted and strange, with laws of nature that defy comprehension. Some trees are mere seedlings, barely beginning their growth, others are ancient giants, vast and complex. The forest stretches infinitely in every direction. Walking through it, you realize that your own tree, the universe you inhabit, is only one among an endless variety. The forest is a metaphor for the multiverse, a realm where the ordinary rules of expectation no longer apply, and every step opens new possibilities. The multiverse also forces us to confront deeper questions about probability and reality. If infinite universes exist, does everything that can happen, happen? Could there be universes where history unfolded entirely differently, where civilizations rose and fell in patterns unrecognizable to us? Where the laws of physics allow forms of matter and life we cannot even imagine? Some theorists argue that, in the multiverse, every conceivable universe exists somewhere, forming a cosmic ensemble of infinite diversity. The challenge is not merely to speculate but to find ways of grounding these ideas in observation and mathematical rigor. As we continue to explore the multiverse, we begin to see that it is not a single story but a symphony of possibilities, each theory contributing its own melody. Cosmic inflation offers the bubbling foam of new universes. Quantum mechanics presents the infinite branching of reality. String theory reveals the vast landscape of possible physical laws. Each approach extends the boundaries of imagination, inviting us to consider realities far beyond the familiar night sky. Yet the multiverse remains elusive, like a horizon we can see but never reach, a reflection of the infinite possibilities embedded in the very fabric of existence. As we stand on the precipice of understanding, it becomes clear that the multiverse is not merely a scientific hypothesis, it is a philosophical mirror, reflecting our deepest curiosities about existence. To grasp the implications fully, we must consider the nature of reality itself. In classical physics, reality was straightforward, a single universe, governed by universal laws, unfolding predictably in space and time. Yet the more we probe, the more that foundation seems like an illusion. Quantum mechanics teaches us that particles can exist in multiple states, that uncertainty is fundamental, and that observation itself plays a role in shaping reality. When these principles are extended to the cosmic scale, the multiverse becomes not only plausible, but perhaps inevitable. Imagine a universe where the constants of nature are slightly different. Gravity is weaker, and galaxies never form. Electromagnetism is stronger, and atoms collapse under their own charge. In these universes, life as we know it could not exist, yet they are mathematically consistent and physically possible. The multiverse suggests that our universe is one of many in a grand ensemble, a rare pocket of stability where stars, planets, and life can emerge. From this perspective, the cosmos is not a single story but a library of narratives, each universe a volume with its own laws, history, and possibilities. Some universes are quiet and empty, others may teem with exotic forms of matter and energy beyond our comprehension. The philosophical implications ripple outward. If every possible outcome occurs somewhere, the notion of uniqueness becomes complex. Every decision, every chance event, might spawn a branching universe in which a different version of reality unfolds. This raises questions not just about the cosmos, but about personal identity. Are we unique in any meaningful sense, or merely one iteration among countless selves? Do our choices matter if every possible choice is realized elsewhere? These questions verge on the existential, blending science with metaphysics, and challenging the very way we understand our lives. Yet, paradoxically, the multiverse can also provide comfort. In a reality with infinite possibilities, the improbable becomes inevitable. The precise alignment of conditions that allows life, consciousness, and thought, conditions that might seem miraculous in a single universe, are simply natural outcomes in the grand ensemble of universes. In this sense, the multiverse offers an explanation for the fine-tuning that has long puzzled scientists and philosophers. We do not exist in a uniquely perfect universe by accident, rather, we exist in a universe that permits our existence, one among countless others where different outcomes have played out. This brings us to a more tangible, albeit speculative, question: could we ever communicate or travel between universes? Current physics suggests formidable barriers. Universes that emerge from inflation or quantum branching are causally disconnected, meaning that signals, light, or matter cannot cross from one universe to another. Even if we could somehow detect a neighboring universe, the laws of physics may prevent any form of interaction. Yet some theorists imagine creative possibilities. Perhaps in extreme conditions, such as near black holes or in the earliest moments of cosmic inflation, brief connections, or bridges, could form. Concepts like wormholes, higher-dimensional shortcuts, or quantum entanglement across universes are still theoretical, but they hint at the tantalizing possibility that the multiverse might not be entirely inaccessible. The idea of a multiverse also challenges the notion of probability itself. In a single universe, events are bound by chance and necessity, the improbable happens rarely. In a multiverse, the improbable happens somewhere, inevitably. Every rare particle configuration, every unlikely cosmic event, is realized in some universe. This reframing transforms our understanding of chance. What is improbable in one universe becomes commonplace when viewed across the expanse of infinite realities. It is a humbling perspective, suggesting that the cosmos is not centered around us or our experiences, but is a vast, impartial tapestry of possibility. Cosmologists also explore the subtle signatures that other universes might leave on our own. Some propose that if our universe collided with another bubble in the early moments of cosmic inflation, the event would create circular patterns or anomalies in the cosmic microwave background. These faint imprints are difficult to detect, easily lost in the noise of cosmic radiation, yet they represent one of the few empirical windows into a reality beyond our own. Similarly, gravitational waves generated by cataclysmic events in other universes might ripple through the fabric of spacetime, reaching us as faint echoes. Though no definitive evidence has yet emerged, these avenues suggest that the multiverse could someday move from theory to observable science. Moreover, the multiverse invites a reconsideration of the nature of physical laws. Are they absolute, or local rules applying only to our universe? In a landscape of countless universes, each with different constants and laws, physical laws might not be universal at all. Instead, they could be emergent properties, contingent on the conditions of a particular universe. This is a radical departure from classical thinking, suggesting that the laws of nature we take for granted are just one pattern in a vast ensemble of possibilities. It reframes science not as a quest to uncover immutable truths, but as a method for understanding the patterns that happen to govern our corner of reality. The implications extend even further when we consider consciousness. If every possible universe exists, does consciousness itself branch along with reality? Could there be versions of you aware in other universes, experiencing outcomes you never encounter here? While this remains speculative, some philosophers and physicists argue that consciousness may not be strictly tied to a single physical reality, but could, in principle, span multiple branches. This intertwining of mind and multiverse touches on questions once considered metaphysical or mystical, now approached through the lens of modern physics. Ultimately, the multiverse challenges our most basic intuitions. It forces us to confront vast scales of space, time, and possibility, revealing that what we perceive as reality is but a fragment of a much larger and more intricate structure. The universe we see, the stars, galaxies, and cosmic web, is only the tip of the iceberg. Beyond it lies a potentially infinite expanse of realities, each following its own rules, each telling its own story. Some may resemble our universe closely, differing only in minor details. Others may be so alien that matter, energy, and even time itself operate in ways we cannot imagine. As we continue to probe the multiverse, the lines between science, philosophy, and imagination begin to blur. It is a realm where mathematics becomes a telescope, allowing us to explore what cannot be seen, where thought experiments illuminate the edges of reality, where questions about probability, identity, and existence converge. The multiverse is a frontier without a clear boundary, a horizon that stretches beyond observation yet compels us to explore. It is, perhaps, the ultimate challenge for human understanding, to accept that our universe may be just one verse in an endless cosmic symphony. As we approach the edge of understanding, the multiverse begins to reveal its most profound implication: scale. Our universe, vast as it is, may be nothing more than a single grain in a cosmic desert of infinite possibility. The galaxies, the stars, the planets, and the intricate web of life on Earth, everything we know, could be replicated, altered, or erased entirely across countless other universes. Some universes may mirror ours so precisely that a version of you exists there, living a life that diverged from yours in the smallest of ways. In others, physics might be so alien that matter behaves in ways we cannot even imagine, giving rise to forms of existence that are inconceivable. To contemplate this is to confront the enormity of reality itself, a humbling experience that shifts perspective and stirs awe. Yet the multiverse is not just about quantity, it is about variety. Each universe is a unique experiment in reality, a canvas upon which nature paints with different rules, constants, and outcomes. In some, time may flow differently, or space may curve in dimensions we cannot perceive. In others, the very concept of cause and effect could be foreign, replaced by a logic utterly alien to our intuition. This infinite variety challenges a core human assumption, that the laws of our universe are absolute. Instead, they may be local, provisional rules that allow life, complexity, and consciousness to emerge here, but not elsewhere. Across the multiverse, the familiar and the strange coexist, offering a panorama of possibilities so vast that even imagination strains to follow. For centuries, humans have asked, are we alone? The question assumes a singular universe, a cosmic stage on which life may or may not exist. But the multiverse reframes this inquiry entirely. In an infinite ensemble of universes, the emergence of life, intelligent, curious, self-aware, may be not just probable but inevitable somewhere. Perhaps some universes teem with life forms utterly alien to our conception. Perhaps civilizations rise and fall in patterns incomprehensible to us, constructing realities of thought, art, and science beyond our imagining. And yet, in the midst of this grand cosmic theater, our own existence gains a peculiar poignancy. We are both infinitesimal and extraordinary, a single consciousness aware of the vastness that surrounds it, capable of contemplating infinities, yet bound to a fragile planet in one particular universe. The multiverse also forces a confrontation with the nature of observation itself. In quantum mechanics, reality is not fully determined until it is measured or observed. If every possible outcome occurs in a branching universe, then reality becomes a constantly splitting tree, with countless versions of existence unfolding simultaneously. Observation, then, is not merely passive, it becomes a kind of participation in the unfolding of the multiverse. Every measurement, every choice, contributes to the tapestry of possibilities. Our experience is both singular and intertwined with an infinite network of other experiences, stretching across realities we may never perceive. Philosophically, this is both unsettling and liberating. Unsettling because it undermines the comforting notion of uniqueness. Our achievements, our choices, our identities, all may have countless echoes in parallel universes. Yet liberating because it situates our lives within a boundless cosmos, a reality where every possibility is explored, every probability realized, every potential outcome given a stage. The multiverse transforms existence from a linear story into a sprawling epic, where the known universe is merely one act among countless others. In this light, significance is not measured by uniqueness alone, but by awareness, the capacity to perceive, question, and marvel at the infinite. Scientists continue to seek evidence. The cosmic microwave background, the faint afterglow of the Big Bang, might hold subtle traces of collisions between universes. Gravitational waves could whisper of distant realities brushing against our own. Mathematics provides a bridge to possibilities that lie beyond observation, a language capable of describing structures so vast that no telescope could ever capture them. Yet even as we search, the multiverse remains elusive, partly beyond proof, partly beyond imagination. Its existence is suggested by elegant theories, by the consistency of inflationary models, by the probabilities inherent in quantum mechanics, and by the boundless landscapes of string theory. It is at once a scientific frontier and a philosophical horizon. Some thinkers suggest that the multiverse offers a radical form of humility. In a single universe, human achievement can feel monumental, the cosmos tailored to our presence. But in an infinite multiverse, we are part of a much larger story, a single note in an endless symphony. And yet, paradoxically, this diminishment is not despairing. It is a call to wonder. To explore the stars, to uncover the laws of nature, to ponder life, consciousness, and the cosmos, these endeavors acquire a cosmic resonance when viewed against the backdrop of infinite reality. In knowing that there may be infinite universes, we are reminded of the grandeur and mystery of existence, of the beauty inherent in curiosity and observation. Even as we reflect on this staggering scale, the multiverse brings us back to the most intimate questions. If countless versions of reality exist, then what does it mean to be real? What does it mean to exist here, in this universe, at this moment? Our lives, our experiences, our awareness, all are part of the vast mosaic of reality, unique in this context but mirrored endlessly elsewhere. Each choice we make, each action we take, resonates not just in our universe but, in some sense, echoes across the infinite branches of possibility. Consciousness becomes both ephemeral and eternal, fragile yet vast, a lens through which we glimpse the infinite. And so we return to the original question: how many multiverses are there? The answer may be unbounded, beyond counting, beyond even imagination. It may be infinite, a number so vast that conventional language fails to capture it. Or it may be a number so large that, for all practical purposes, it feels infinite. Perhaps every conceivable universe exists, every permutation of physics and probability realized somewhere in the cosmic expanse. Perhaps some realities are so alien that even the concept of life, matter, or time is meaningless within them. What we call existence, the universe we inhabit, is just one thread woven into an infinite tapestry. In the end, the multiverse transforms our perspective, forcing us to confront both the majesty and the mystery of reality. It reminds us of the fragility of the familiar, the limits of perception, and the boundless possibilities that lie beyond. We are explorers on a cosmic shoreline, gazing into an ocean of universes, each waiting to be imagined, each a testament to the richness of existence. The question of how many multiverses there are may never be answered definitively. Yet in asking it, we expand the boundaries of thought, glimpse the infinite, and recognize our place within a reality far larger, far stranger, and far more beautiful than we ever dared to dream. The multiverse is, in the end, an invitation to wonder, to explore, and to accept that reality is far more expansive and mysterious than we have ever imagined. And in that recognition, we find not despair, but awe, a profound, quiet understanding that existence, in all its infinite forms, is more extraordinary than any single mind can contain.